In the last section of Chapter 7, we want to look at those types of reactions we looked at and look at their classification according to what things are doing. So we looked at different kinds of chemical reactions. We looked at precipitation reactions, okay, and we looked at complete net ionic equations with those. We looked at acid-base reactions. We looked at gas evolution reactions, which note that acid-base reactions, a lot of those do evolve gas as well. So they actually can fall under two categories. Okay. We looked at oxidation reduction reactions and then a special type of oxidation reduction known as combustion. Okay. So those are just types of chemical reactions, but what we can do is look at the reactions in more generic terms, in terms of what the atoms are doing. So we're not looking at specific types of compounds. We want to say, what is it if we have A, B, C, D, and they're doing whatever. So if we look at the reaction of compound A, whatever it is, plus compound B, I have two separate elements or compounds, and they combine together and bind together to form compound AB. This is known as a synthesis or combination reaction. Now, the reverse of that, if I take some compound AB that's bound together and break it apart into its constituents A and B, that's the opposite. Instead of combining them, I'm decomposing it. That's a decomposition reaction. Now, the other thing I can do, I can have some compound A and a compound BC. So A would be an element by itself, let's say. BC would be two elements combined in a compound. And what I can have is A can come in here and knock B out of place. Okay, so that A and C are now combined, and B is an element by itself. What A has done is displaced B in this reaction, so that is known as a single displacement reaction. One thing got displaced. And then the precipitation reactions we were looking at, in more generic terms, we can think of it as double displacement. So compound A comes over here and displaces C by picking up D. And then C comes over here and displaces A by picking up B. So I have now AD plus CB. So I had two cations and two anions, and they swapped. That's that partner swapping again. That is generically known as a double displacement reaction. Okay, so here's four broad categories of reactions that we have. And then those reactions we looked at, the combustion, the gas evolving, the acid base, can all fall under one or more of these generic types of reactions. So, if we look at just where the atoms are and where they're going, we can have precipitation reactions that are double displacement reactions. We can have combustion reactions that will be single displacement, or they may be decomposition, or depending on what we're looking at. All right, so looking at each of those categories a little more specifically. In a combination or a synthesis reaction, we said that we have two simple substances that come together to make a more complex substance. This would be like reacting sodium metal that they have in the little reaction vessel right here. There's a little lump of sodium metal. They're showing it in a molecular view right here. And then the sort of yellowish green gas you see in the container is your chlorine, okay, which they're showing in the molecular view right here. And if I provide a little bit of a heat source just to get the reaction going, it's a little bit hard to see in here, but what you've got inside that spoon where the sodium is, you have a reaction going on, you've got a little bit of fire going there, you see a lot of smoke. Okay, they're combining together, and now at the end, if you look in the container, we have these white crystals of sodium chloride or table salt. So this is a synthesis reaction, a combination reaction. I've combined sodium and chlorine to create a new compound, sodium chloride. Decomposition reaction, we're taking something and breaking it down. So for example, if I start with water, and I put an energy source in there, such as a battery. I can electrolyze this water. I can pass a current through it. It breaks it down, and H2O will form hydrogen gas and oxygen gas. Okay, so they're showing the hydrogen and the oxygen here. So I went from a compound to two elements here, decomposition. If I have something like a single displacement reaction, this may be, for instance, the reaction of metal with an ionic compound or an acid. And the example they're showing is the reaction of zinc metal with an ionic aqueous solution of copper chloride. So remember, it says aqueous, so I have copper ions and chlorine ions in solution. The copper are the ones that are more copper colored, the chlorine are the ones that are green. And when I put it in the reaction, because of a difference in electrical potentials, which again, we're not looking at that right now, but the electrical potential is different between zinc and copper. And so what happens is the copper will be displaced from the solution, and it displaces the zinc. So basically the copper will start plating itself out on the piece of zinc, and in the process it kicks all these little zinc ions out into solution. So I end up with zinc chloride and then solid copper. Eventually I would have nothing but copper metal and zinc chloride in solution if I let it go long enough. All right, the double displacement reaction, we've already looked at several examples of that. That's where we get two cations swapping their anions. So precipitation reactions, all those complete net ionic equations we looked at, those deal with double displacement reactions. Acid-base reactions are double displacement reactions. And then gas evolution reactions very often are double displacement reactions. So that one's actually a pretty broad category. That one overlaps with a lot of the types of reactions. Okay, so that was just a quick overview of some of the terminology, just so if you hear those talked about, you know what we're referring to. And then you do have another chemistry in the environment clip in your book. Just want to point that out because it does involve a lot of these types of reactions that we're looking at. And it's basically the reactions that are involved in the depletion of ozone. We talked about that a little bit already in Chapter 6, chlorine and chlorofluorocarbons. So the chlorine, we said, is responsible for helping to deplete the ozone layer. And so what's happening is, okay, here's what we do to make ozone in the first place. We have oxygen gas plus what we call an oxygen radical, just an oxygen atom by itself, not bound to anything. Those come together, and the oxygen radicals get formed from being bombarded with energy. It knocks an O2 molecule apart. Now I've got two free oxygen radicals. They are not going to stay that way very long. They can either find each other and come back together and form O2, or they may find another O2 and form ozone. All right, now with the chlorofluorocarbon, when it gets hit with ultraviolet light, it causes a chlorine to be released from that chlorofluorocarbon. So now I have chlorine gas floating around, and if that chlorine happens to find the ozone, I get the reaction that I see here. It forms ClO, which is a kind of gas, and then O2 again. And then it can become difficult for that O2 to form back to ozone, because now the free radical oxygen it normally would have taken on has been bound by chlorine, and it's very difficult to pull it away from the chlorine. Okay, so it basically pulls that oxygen out of there, but another oxygen radical can come along, pull it off and make an O2. Now the chlorine's free to go scavenge again, but notice that the oxygens from the chlorine tend to go back to forming O2 and not O3. You end up missing a lot of your ozone. Okay, so you're not building up more ozone, and the ozone itself is getting broken down. through the reaction with ultraviolet light. So if we go through a lot of cycles of these reactions, we end up depleting a lot of ozone. But if you look at all these different reactions, one thing I would challenge you to do is take a look at these and see if you can recognize any of the generic types or the specific types of reactions we're talking about. So do you see any single displacement reactions? Do you see any double displacement reactions? Do you see any synthesis? Do you see any decomposition going on? Go ahead and classify those 4 broad types, and then see if you just happen to see anything like an acid-base or precipitation or anything like that. You may not see those, gas evolving. See if you can spot any of those, but you can definitely put it in one of those 4 broad categories. So synthesis, decomposition, single displacement, and double displacement. See if you can categorize these 5 reactions into those 4 groups. Okay, and that wraps up Chapter 10. Chapter 7, I wish we were on Chapter 10, and Section 10 of Chapter 7, and we will start on Chapter 8 coming up soon. So go ahead and get yourself caught up on Chapter 7, and we'll see you in Chapter 8.